Hi, my name is Keith Lacuna, and my project for Insight Data Engineering is Close Calls. Close Calls is a batching data pipeline to analyze flight tracking data and detect when airplanes get too close to each other. The primary audience for this is aviation enthusiasts like myself, but I think anyone getting off of a plane might be interested to know how close their flight got to another. Also, airlines, insurance companies, and governments might be interested in this information. The data is basically a series of points with a timestamp, a position, and an altitude. I have about 1 billion points per day, which is around 80 gigabytes. And my approach is to use Apache Spark to detect pairs of points that are close to each other. From there, those points are output to MySQL. MySQL serves the front-end visualization and also detects the closest call between those two planes. This process outputs around 8 megabytes of data from around 80 gigabytes. Here's the entire pipeline. Apache Airflow is used to direct most of the work. The data source is adsbexchange.com, which is a flight tracking service. They offer a free tier of sample data that I could use. This data is stored in S3. The batch processing is done in Spark and is output to MySQL. The visualization is a Node Express app, which with a front end in a JavaScript framework called Aurelia, and also the Google Maps API. The Airflow workflow could be directed to process new data every day, but I don't do this because it would be too expensive. Here's the live demo, which is using the sample data set of 4 random days over the past year. This is the web app. With the dropdown, you can choose what data you want to look at. You can also type in a call sign and search the database for a specific plane. Each point on the screen is the closest call between two airplanes, and if you click on a point, it'll load all of the data for those two planes. At the bottom of the screen is a table displaying some information about these close calls, so we can see the distance, the position, and also the call signs for each aircraft. Here's an interesting example that I found. I ended up detecting a lot of military flight data. So this is actually a training flight off the coast of San Diego between 2 fighter jets. Here's some engineering challenges that I solved. The first was in ingesting data. The data was stored in 1-minute files. Each airplane had 1 row, and the positions for that airplane within that minute were stored in an array. And each airplane had between 1 and 60 positions for that minute. The problem was that the positions array was not really structured data, it was just a list of numbers. So the first challenge was to create a distributed function to iterate through that array and explode a new row based on the modulo of the position of the element in that array. And so this output around 700,000 lines from around 50,000. The next challenge was detecting close calls. My initial approach was to round each airplane's position to the nearest position, but the problem with rounding is that planes can be rounded away from each other into separate squares. Here's an illustration of 2 rounding strategies that didn't work. My solution was to find the absolute difference between positions for each plane. And so this is kind of like drawing a box around each aircraft. And this is a pseudocode of how I did the self-join on the right side of the screen. The final engineering challenge was making my pipeline run faster than real time. Initially, it took about 5 minutes to process 1 minute of data, but I was able to get this down to 20 seconds. I did this by efficiently parallelizing the explode step that I mentioned. The next thing was using the timestamp as the join key on that self-join step. And this caused the data to be shuffled efficiently. Next, I increased the number of cores in my cluster. And finally, I removed print statements and unused data in the data frame. Thank you very much for watching my presentation. Again, my name is Keith Lacuna. I'm from Hawaii. I have a background in web development, and I really enjoy rock climbing, being outside, and I think aviation is really cool. Thank you.